Welcome to the video on problem solving exercises. In this video, I will go over an example of a non-linear case where we will compute the GDP as we have done in the case of linear functions. So let's say that we are given that the household consumption C is specified as 25 plus 6 square root of y. Y is the national income, and then so this is the household consumption. Let's also say that the private investment is given to be 16. The government expenditure is given to be 14. And for simplicity, we will assume that the net export is 0. So given this specification, I can first determine what is the aggregate expenditure C plus I plus G plus NX, and I have 25 plus 6 square root of Y, that's the household consumption, 16 plus 14 plus 0, that's the other three terms. I combine the constants together. So 16 plus 14 is 30 plus 25, we obtain 55 plus 6 square root of y. Now we have the aggregate expenditure in equilibrium. The aggregate expenditure must equal the national income. Y, the national income, is equal to the aggregate expenditure 55 plus 6 square root of y. So notice we have a non-linear term on the right hand side, square root of y. I can rewrite this as y minus 6 square root of y minus 55 equal to 0. So even though it is a non-linear case, but we still have one equation, one unknown. And just to see how we are able to solve it, I will rewrite this equation slightly differently. I will write y to be square of square root of y, 6 square root of y minus 55. So from what we have in the previous equation, now we can see I have transformed it into an equation with square root of y being the unknown. And now this is a quadratic equation because the first term is raised to the power 2, and that's it. The remaining terms have power less than 2. So it is a quadratic equation. And there are multiple ways of solving this. One particular way of solving this equation is to come up with factors, two real numbers, such that when I multiply those two numbers, the answer is negative 55. And when I add those two numbers, the answer is negative 6. So if you can look at these two requirements, and maybe you can see minus 11 and plus 5 are the factors. They do this job because minus 11 multiplied by 5 turns out to be negative 55. That's the first requirement. And then I add them together, minus 11 plus 5. The answer is negative 6, which is the coefficient here. So that should give us as these two factors for the equation at hand. I will rewrite it. I will write root y square. The way we solve this, I will rewrite this minus 6 root y to be minus 11 root y plus 5 root y. You can see added together they lead to minus 6 root y. Then I have minus 55 equal to 0. Now we can find out common terms between the first two, similarly common terms in the next two, and see whether we are able to factor this equation. So you can notice between the first two equations, square root of y is common. It is raised to the power 2 here, and it is there by itself. If I factor out square root of y, what remains in the first two terms is, the first one gives me square root of y, and the second one gives me 11. Then if I look at the remaining two terms, you can see 5 is common factor in both. So I take it out. What remains from the third term, 5 square root of y, all that remains is root y, square root of y, and the last one, 55 divided by 5 is 11. So that helps in coming up with the factor we are looking for. Now you can see I have square root of y minus 11 here, square root of y minus 11 here. I can factor this out, and what remains is square root of y from the first term plus 5 to be the second term, and that's it. That's the factor, which means the original equation can be written in this form. And so now we are ready to get the solution. Two numbers multiplied among themselves leading to an answer equal to 0 implies at least one of them has to be 0. So we have either square root of y minus 11 being 0, that gives me square root of y to be 11, also which gives me y to be square of 11 square, or y is 121. I will put a star. I want to claim this is our solution, but I will also like to look at the other one. Or I have root y plus 5 equal to 0, root y equal to negative 5, and this I want to reject as infeasible, because income, the national income, is a positive number, and I am looking at its square root to be a positive number as well. Square root of y should not be negative. So we say square root of y equal to minus 5 is not feasible. So all I have got is y star to be 121. I can also find out now what is the household consumption. Household consumption is given to be 25 plus 6 square root of y, 25 plus 6 square root of 121, which gives me 25 plus 6 times 11, that is 25 plus 66, gives me an answer of 1 here, 6 and 2, 8, 91. So that will be the household consumption in equilibrium, called C star to be 91. I already know I is given to be 16, the government expenditure is given to be 14, net export is 0, gives me y star to be 121. So all we have noticed now is, even when we have non-linear case, functions which are given in non-linear form, the technique of finding out national GDP in equilibrium remains same. I make national income y to be equal to aggregate expenditure. Only the solution of the emerging equation becomes little different or involved. And this is a good point to stop.